Welcome to this video number 3 on load flow analysis. In this video, we shall continue with our learning outcome number 1, that is load flow problem, and particularly we shall look here at the type of buses. Now already in the previous video we have seen that there are 4 variables defined in the power system, that is P active power, net active power, Q net reactive power, voltage magnitude at a bus, and the phase angle associated with that. Now out of these 4 variables, 2 variables, they are taken as independent variable and 2 they are taken as dependent variable. Now which variables they are taken as independent and which they are taken as dependent variable, depending on that we have 3 type of buses defined in the power system. The first one is slack bus. Now slack bus, there are different names. It is also called as swing bus, also it is called as reference bus. Now at this bus, what is specified? Here V voltage magnitude and its associated phase angle, they are taken as independent variables, or they are specified. We can say these are specified. And the other 2 variables, that is P and Q, they are not known. They have to be calculated. Okay, so what is slack bus, swing bus, or reference bus? It is a bus where voltage magnitude and its phase angle is specified and P and Q are to be calculated. Similarly, at PQ bus, there is another bus called as PQ bus, a load bus. Here, P and Q are specified and voltage magnitude and angle, associated angle, they are to be calculated. These are specified and this is to be calculated. Then the next, it is called as PV. There are different names: generator bus or voltage control bus. At this bus, P and V magnitude, they are specified. As the name indicates, PV. PV means P and V are specified, and delta, Q and delta, they are to be calculated. They are to be calculated. Okay, so again, let us have a detailed explanation of this slack bus. So as I given here, slack bus is also called as swing bus, or it is also called as reference bus, different names. So as I already told, V and angle, they are specified, and real power and reactive power, they are to be obtained at this bus. Normally there is only one bus of this type in the given power system. This is very important to be understood. In the given power system, there should be at least one swing bus. We have to specify. We have to specify, and there will be only one swing bus. We cannot have 2 swing bus in the power system. And normally the first bus, it is taken as number 1. It is taken as reference bus or a swing bus. And this swing bus, the generator is selected as the reference bus. Means the bus where the generator is connected. Which generator? The highest generator into the system. Now, for example, in Maharashtra state, as we have seen that in the Chandrapur, we have a largest thermal power plant, which is of around, I think, 2400 megawatt. And this generator bus. Now, here we have a bus, and to this we have this plant connected. Now this bus in the power system, it is taken as swing bus. Okay, because this generator, actually this Chandrapur plant will dictate the operation of the entire Maharashtra electricity. So it is called as swing bus. Then in the slack bus, voltage angle and magnitude are normally considered as 1 JPU. What it means that? It means that here we are here we are given the voltage magnitude and angle, and this normally it is taken as 1, magnitude is taken 1 and angle is taken at 0 normally in the power system. Okay, uh, now let us come to load bus or PQ bus. Load bus, as the name indicates, you can see that. Suppose if I have a Kolhapur, now I have a Maharashtra state and I have a Kolhapur city. Now at Kolhapur city, now and there must be one substation where the power comes for the Kolhapur city. Now this bus where the entire load of Kolhapur city is connected can be taken as a PQ bus, where the load, reactive power and reactive real and reactive power requirement of the Kolhapur city is specified. So here we are connected a load where P and Q are specified, but voltage at this will not be known. The voltage at this bus will not be known. So that is what we have to determine in the load flow solution. So voltage magnitude and phase angle of the voltage will be calculated. Now 80% of the buses in the power system, they are on this type. They are called as PQ bus or load bus. Then the next one is called a generator bus, PV bus. There is another name also, voltage control bus. We will try to understand this, why it is called as voltage control bus also. So at this bus, as the name indicates, at this bus, P and V are specified. Normally, there are some generators in the, say, Maharashtra, there are some generators, let us take it as Koina. Now, Koina, there is a bus, and this bus we can take it as a PV bus. Now, what is P? Now, this generator, this plant will give you some fixed power. We are not going to vary, we are scheduling this power, that this power plant will give this fixed power, say 200 megawatt. This power it will give fixed. Then with excitation control system, now we are maintaining the voltage also at this bus. Okay, now we are controlling power 200 megawatt and we are controlling voltage at this bus. So P and V, they are given. Now what is not given? Q and delta, this is to be calculated at this bus. So there are names called as generator bus. Why it is called generator bus? Because generator is connected to that. Okay, it is also known as PV bus. This bus is connected to the generator. This type of bus is it is 10% of the buses in the power system, they fall into this generator bus. Now, what is voltage control bus here? This is to be understood. What is voltage control bus? Now, uh, now at some buses in the power system, yesterday we have seen, at some uh, buses in the power system, we are connecting fact devices. Now, why these fact devices are there? Like they can control, they are there to control the voltage in the power system. So we can control at this bus. So it is called as voltage control bus. Also, this bus also it is taken as PB bus. The power injected, no power is injected, zero. We are not injecting any power from these fact devices, but we are controlling the voltage at this bus. So it is taken as PV bus. So the PV bus, also called as voltage control bus, their generator are not connected. There are voltage control devices like your fact devices. They are connected to that. So here it is the table given. So a slack bus, as I told that V and delta they are specified and P and Q they are unknown, which is to be calculated. And at PQ bus we can see here P is specified, Q this is also specified, and we have to calculate the voltage and its associated angle. PV bus where P is specified, you can say P is specified, V voltage it is also specified. We have to calculate the other two unknowns Q and delta. Okay, so this is, you have to understand that There are four variables in the power system: P, Q, V and delta. Depending on which are specified and which are to be calculated, we have these three type of buses: slack, load bus and voltage control or PV bus. Now, what is the significance? This is a special question they ask in the exam. What is the significance of slack bus? As I already told in this explanation, that the biggest generator, the biggest player into in the system, that is, for example, we have a biggest power plant in Chandrapur. So that generator plant will play a dictating role in the power system. So the bus connected to the generator, it is taken as swing bus. And in the power system, there will be only one swing bus specified. Okay. Now why we are selecting one bus as, and here we know that at the slack bus, P and Q are not specified. So we have to calculate. We will try to find the answer to this. Why P and Q are not specified, and we have to calculate that after load flow. So let us understand with this here. Okay, let's understand it with this example. Now, in this example, initially, suppose my load is here. So I will just show you the load. Right. Okay. Now here the load is given 400 megawatt 250 MVAR load. This is my load at this point. Now this much power we have to give it from this generator and this generator. Now what is specified to us, we can see here this bus whatever here it is. Okay, I will just, now this is our PQ bus. We can say that this second bus, it is our PQ bus. Why? Because P and Q are specified. So we can take this as our load bus or a PQ bus. Now this bus number 3, now it is given as PV bus. Why it is given as PV bus? We can understand. Now we can see here this P is given, that is 200 megawatt. But Q is not given. Q 0. Now initially it is taken as 0. Now one more point is given. The voltage is given. You can see here this voltage 1.04 pu. So P is specified, V is specified, so that this bus we can take it as a PV bus. Okay, at this bus now we have to calculate Q and we have to calculate delta. Okay, and here at this load bus PQ, P is specified, Q is specified, we have to calculate voltage. We have to calculate voltage and angle. We have to calculate these two parameters. Now you can ask, sir, voltage is specified here. No, this is, we are taking it as assumption. To start a load flow problem, we are taking this as an assumption. Okay. Now this is bus number 1. Now we have to define it as slack bus. Now here slack bus means what? V and delta are specified. So we can see here the voltage value is given 1.05 and angle is specified as 0. We have to calculate P and Q. What is the active power and what is the reactive power to be given by this generator? Now what is our question is that why we are selecting one bus in the power system as swing bus. That is our question. Now let me take what is PL in the system. What is total power in the system? So now our power balance equation I will write here. P generator, that is the total power generated in the system, and also I will take reactive power, uh, you know, uh, reactive power balance equation. Now, if you look, these are called as power balance equation. Now, this PL is given, that is 400 megawatt. You can see here, this is our total load in the power system. We don't have any other load except this. So, total load in the power system is 400 megawatt. And what is QL? QL is also given as 250 MVAR. Now initially we can see here what is now in this PG, what is total power generation. You can see here 200 megawatt is there, 200 megawatt, and there is some generation from this. I don't know what is that, so I will take it as PG1. And QG, this is not entirely not known. Here you can see that this generation is not known, and here this generation reactive power generation is also not known. So what is what is, and also P loss and Q loss is not known. Okay, so what we have to do, we have to select one swing bus, one generator as swing bus, so that the difference in the load and the losses, the difference in the generation and load plus losses, they are supplied from this slack bus. So it is necessary in the power system, one bus we have to take it as slack bus, which will supply the difference in the generation. Now you can see here, what is the difference in the generation? This is 400 is our load. So we have to generate, 200 is already given. One generator is generating 200 megawatt. Now we are expecting this generator to generate 200 megawatt plus losses in the system. But we do not know what is the loss in the system unless and until we do the load flow. So one bus we are taking, a swing bus where P is not specified, and this generator will supply the difference in the generation and load plus the losses. So this statement also holds good for reactive power. Now we can see here, now our total reactive power demand is 250 megawatt. Now we have to generate this much, plus losses plus reactive power, but reactive power loss is not known at the initially. So one generator we have to take it as slack bus where Q is not specified. So that we have to calculate. So this is the significance of this. Okay, so while specifying here it is written, though we have to write the same thing in the exam also. While specifying the generation schedule for the given power system, one can fix up the generation setting of all the generator buses except one bus because of the limitation of not knowing the transmission loss in advance. That is what we will be knowing the load, but will be not knowing the generation. Entire generation will not be knowing, and also will not be knowing the losses. So for that one generator you have to select, so that generator will supply the difference in the generation and load plus the losses. So real and reactive power are not specified for slack bus. After the power flow has been solved, the difference between the load specified real power going to the system at all the buses and the total power consumed by the load plus I square R losses are assigned to that slack bus. Therefore, generator bus will be selected as slack bus. Okay, so this is very important. You have to understand that what is the significance of slack bus. One bus in the power system is taken as slack bus in the power system. Okay, so in this video, up to this only. Thank you very much. We shall continue in the next video.